This is Euclid Book 7, proposition number 34, and I'm going to start by showing you this diagram. This will be part 1. Okay. And yes, there will be a part 2 to this. Alright. You'll see why in a little bit. Given two numbers, to find the least number which they measure. Let A and B be the two given numbers. Okay, we have 9 and 6. Thus it is required to find the least number which they measure. Now A and B are either prime to one another or not. In this particular case, I showed you that they're not, even though I'm going to read it as though they are. Because later on I'm going to show you what's going to happen when we do make the two numbers prime to one another. Okay. First, let A and B be prime to one another. Now I will show you that in a little bit. And let A, by multiplying B, make C. Okay, well, 9 times 6 is 54. And C, of course, is 54. Therefore, also, B, by multiplying A, has made C. Well, 6 times 9 is 54. Therefore, A and B measure C, which is by Euclid Book 7, proposition number 16. I say next that it is also the least number they measure. For if not, A and B will measure some number which is less than C. Let them measure D. That's why I used the numbers the way I did, because 9 and 6 will both measure 36. We're going to make D 36, and 9 and 6 will both measure 36. Then, as many times as A measures D, so many units let there be an E. Well, 9 measures 36 4 times. Okay? And as many times as B measures D, so many units let there be an F. Well, 6 measures 36 6 times. Therefore, A, by multiplying E, has made D. Well, 9 times 4 is 36. And B, by multiplying F, has made D. Well, 6 times 6 is 36. And this is by Euclid Book 7, definition number 15. Therefore, the product of A and E is equal to the product of B and F. Therefore, as A is to B, so is F to E. As 9 is to 6, so is 6 is to 4. And that's true. And this is by Euclid Book 7, proposition number 19. But A and B are prime. I know they're not prime right now, but I'll show you what happens when we do make them prime. Primes are also least, and the least measure the numbers which have the same ratio, the same number of times, the greater, and the less, by Euclid Book 7, proposition number 20. Therefore, B measures E as a consequent. So what they're saying now is that 6 is going to measure 4. Do you see a problem with that right off the bat? But it gets worse. And since A, by multiplying B, has made E, because 9 times 6, okay, I'm sorry, and since A, by multiplying B and E, has made C and D, okay, 9 times 6 is 54, and 9, I'm sorry, okay, 9 times 6 is 54, because A is 9 and B is 6, and 9 times 4 is 36, which is your D. Therefore, as B is to E, which as 6 is to 4, so is C to D. That means as 54 is to 36. This is by Euclid Book 7, proposition number 17. Now that actually works out. But B measures E, which we've already established the 6 does not measure 4. Therefore, C also measures D. Well, 54 does not measure 36. The greater the less, which of course is impossible. Now you say, well, what about you said that you were going to show us how this would work if you were to make this prime? Okay. Well, now we're going to change the 6 to a 4. Okay. And C will then become 36. And as you will begin to see, because 9 and 4 are definitely prime to one another, there is no number that both of these will measure that is less than 36. And that really just pretty much defines the entire proof. Okay? But that's part 1. I will be showing you part 2 in a future video, so stay tuned.